could outsmart cancer. How do you know it is specific really to that cancer and not to healthy human cells in that particular patient's body?
That was actually the last 2 decades which we invested in to identify how we get the best targets, the best mutations, the best molecules to recognize cancer cells and distinguish them from normal cells.
Remember how mRNA works in COVID-19 vaccines? It essentially gives our immune system detailed instructions to make a specific part of the virus, so our immune system can then learn to recognize it and create antibodies against it. Those instructions can then be tailored and tweaked quickly if the virus evolves. The idea is this could work in a similar way, but for cancer.
The optimal technology to be able to custom make a vaccine rapidly in real time, which is really important for a cancer patient who wants care. The best technology out there, we thought, was mRNA.
Let me explain how this worked for Barbara. Doctors first removed her tumor, and a sample of it was flown almost 4,000 miles to BioNTech's headquarters in Germany.
What we do is we sequence the tumor, the DNA from the tumor, and identify the mutations by comparing the DNA from the tumor with the DNA from the blood, because the blood is non-mutated, and then you can see, oh, at that position there's a mutation.
The next step involves using a computer algorithm to figure out which of those mutations should become targets for the vaccine, the ones that Barbara's immune system will recognize and then deploy T cells to fight against. It took just about 6 weeks for Barbara's custom cancer treatment to be created. And once it made it back over the Atlantic, the first vaccine dose was infused into her blood. That was December 15th, 2020, around the same time the mRNA vaccines for COVID became available. Along with her standard chemo and immunotherapy, Barbara has received 9 mRNA vaccinations. And she says everything is so far, so good.
Had one last immuno last September, which I also had a CAT scan at that time, and it was negative for pancreatic cancer. And everybody is celebrating. But whatever time I have, it's given me more time to enjoy my grandchildren and my children and my life.
It is such promising science, and it's so cool. I mean, we're talking about individualized immunotherapy, basically teaching your body to fight your own specific cancer. As you heard, these are early days. As you mentioned, it's been happening for some time, this work, but now these trials are just now underway. So phase 1 trials are finishing up, phase 2, phase 3 to come. But look, if this works, again, an individualized immunotherapy for very, very hard to treat cancers, guys.
Look, it opens up whole new doors in medicine, Sanjay, and it really would be wonderful if you can see these second and third level effects from some of the technology that's become so important in other ways over the last few years. Terrific report. Great to see you, Sanjay. Thank you.